Welcome to qnawire.
Here we're going to answer the following questions regarding ideal gas law. In this case, this is going to be our expression for ideal gas law, and we're told that the pressure in Vehus is going to be equal to 1,350 psi's, which, after transformation to atmospheres, knowing that 0.068 atmospheres is going to be equal to 1 psi, we know that the pressure on Vehus would be equal to 91.868 atmospheres, using the values that were provided over here. The temperature in Vehus is equal to 467 degrees Celsius, which in Kelvin, using the conversion factor of just adding 273, which corresponds to 740 Kelvin. So these are the values that we're going to employ for solving these questions. First of all, let's calculate the value of our gas constant R on Vehus. So R would be equal to, according to our ideal gas equation, PV divided by N times temperature. So the pressure is 91.868 atmospheres. We have 1 liter. The number of moles is going to be 1 mole. And the temperature is going to be 740 Kelvin. So our value for the gas constant R would be equal to 0.124146 liter atmosphere over mole Kelvin. So this is going to be the value of R that we're going to employ from now onwards. Actually, in one of the questions, you just stated this part over here. So the result on the previous question is not going to be correct since we were not provided the value for R on the plant Vehus. Okay, so here we're going to do it again. Now, using this value of R from question 1, what is the mass of 2.25 liters of oxygen? And in this case, what we're going to do is, in order to get the mass, this is going to be equal to the number of mole times the molecular weight of the compound. But the number of mole is going to be equal to PV divided by RT. So our result over here would be the pressure in this scenario is 83 atmospheres. The volume is going to be 2.25 liters. The R constant would be 0.124146 liter atmosphere over mole Kelvin. The temperature in Kelvin, it would be 325 degrees Celsius, so temperature is going to be equal to 325 plus 273, which is 588 Kelvin. As you can see, our result is going to be in moles, and next we're going to employ the molecular weight of oxygen to get the result. In this case, we're going to have a molecular weight of 32 grams per mole. So the result for the mass is equal to 80.487 grams of O2. And finally, we're going to have 5 moles of gas on the surface. What would be its volume at 25 degrees Celsius? So the volume, again applying ideal gas law, would be nRT divided by P. The value for N is going to be 5 mole. The value for R, the one that we calculated over here, 1241.46 liter atmosphere per mole Kelvin. The value for temperature at 25 degrees Celsius, this is going to be a temperature of 298 Kelvin. Over my pressure on the surface of Vehus that we said that was 91.868 atmospheres. So with this, the volume would be equal to 2.0135 liters. So over here, I give you as many significant digits as possible. In this case, you just need to round off to the ones that are required by your professor. And with that, it would be all. Thank you very much and have a good one.